Good afternoon. This is Dr. David A. Paget, and I am at Tennessee State University, and this is part 2 of Earth Week at the Geographic Information Sciences Laboratory at TSU. And so this is the second part of our student presentation. Specifically, they will be doing map presentations using data from their earlier this semester completed Global Learning and Observations to Benefit the Environment Atmosphere Protocol data collection. Some of the students, the pre-service teachers, will be using the Globe Data Visualization System map to present their data. The remaining students will be using ArcGIS Online. So the assignment, the first group that will come up will be the pre-service teachers. And the assignment they completed is as follows, as you can see on the screen. And so the entire class went outside at the end of March and completed the Globe Atmosphere Protocol atmosphere data collection process. And then they were, they mean pre-service teachers, were assigned the task of converting the Globe data from the Globe data collection sheets onto this form, as you can see here. And then they went through the process of data entry. So the first iteration was to do data entry using the desktop portal, as you can see here. And then the next iteration, so they did that for our first site. So our first site was called the Old Courtyard Northwest Corner site at Tennessee State, or at the Tennessee State University Globe Partnership. Our second site is the Tennessee State University Old Courtyard Lawn site, which has a different surface cover. The teachers were instructed to use the Globe Observer app to enter the data in the second iteration for the Old Courtyard Lawn site. So they first recorded the data here. Should have had a satellite match there. And then they were to proceed forward, visualizing their data in the Globe data visualization system. And then, of course, after completing that step, their data points would be visible on the Globe data visualization map. So our first group of students will use the Globe site. And so our first group, I believe, will include all of our pre-service teachers. And we will figure out how that's going to work in a moment. So let's see, we have Miss Jackson, Miss Berry, Miss Tyree, Miss Rogers, and Miss Thompson. So they are group one. So we have all of our pre-service teachers working together. And as you know, Globe is primarily a program that's aimed at improving K through 12 education at the, well, K through 12 science education. So we'll have group one come forward. Cameras right there. We are recording. Unfortunately, so far we don't have any guests. I'm surprised at that, but anyway, I'm going to post this online later. So we'll have Miss Jackson, Miss Berry, Miss Tyree, Miss Rogers, and Miss Thompson to get us started as we do our our Earth Week observation, and I will walk you through the process. Don't worry. So come on up, look in the camera, introduce yourself, your name. He's just pre-service teacher. That you just podium. Just your name, your major, your classification, where you're cameras up.
Is everybody?
Yeah, your name, your major, your classification, hometown.
My name is Nicole Jackson. I'm an elementary education major. I'm from Atlanta, Georgia, and I'm a freshman.
My name is Jemina Tyree. I'm an early childhood education major. I'm from Cincinnati, Ohio. Oh, and I'm a freshman.
My name is Malia Rogers. I'm an elementary. I'm from Memphis, Tennessee, and I'm a freshman.
Okay, so since Ms. Jackson is right there, would you mind like logging in to go? Remember your.
Mine was one that was having the issue. And I
Oh,
don't
that's true. So Tyree or Tyree, can you do the logging? Your password, you got your password. Well, I'll just log in, save ourselves some time here. I'll just do the login. Hopefully this won't cause a problem. We'll see. Let's see here. I don't know if this is going to make any difference. We'll see. Okay, so now go to Flow Data. Ms. Jackson's going to be our pilot. Visualize data. Then scroll down visualization system. Visualization system. There you go. And wait a couple of minutes, couple seconds. Okay, so you remember how to get to your data?
Or was able to get in.
No, you don't. One of the other teachers that navigate to your data.
I don't know.
Did this, did turn in your assignment, the other teacher. Okay, we got it. Yeah.
It was air temperature?
Yeah, we did air temperature.
Okay.
Yeah, we did air temperature.
It was, I think the other one was surface.
We did cloud, You know, we did contrails, short-lived, I think we had short-lived contrails. Yeah, keep going down, we did surface temperature. There, and I think that was it. Then, a couple of seconds. Okay, so we're gonna change that date. I think this class went on March 30th. Okay, now I'm gonna zoom in to TSU campus. Now I'm gonna ask you all some questions.
How can I zoom in?
Zoom in. Oh, this you can either scroll, zoom. There you go. Tennessee. Yeah, there we go. And zoom in a little, zoom in more. So see. Yeah, close that pop-up box. Just wait.
Oh, yeah.
Yeah, okay, go back. Just drag it over and go. You might have to drag the whole screen.
The map.
Grab this, the map and just drag it. Whole map.
The whole map?
Yeah, there you go. Now close it. All right, zoom in on the next, kind of see you. Keep zooming in, zoom in, more, center, center, it's good news, at least we have some data. Zooming in. Zooming in, going. Center, center. Yeah, I guess that's okay. Okay, click on this little arrow here, this little icon. Click on the three dots. Okay, click on choose base map. Change it to satellite. Okay, so now we have, and zoom in a little bit closer. All right, so this looks good so far. We have our two sites here. We have the Old Courtyard Lawn site. And we have the Courtyard Northwest Corner site. Bring the legend up. Legend's on the lower right hand corner. And I think we're on average surface temperature. And it looks like they're about the same. Let's click on the point symbol just to make sure that we are accurate. So we close that measurement value. Legend. See, let's go to the Old Courtyard Northwest site first.
So what's that? Is this?
Yes, the one with the orange. Yeah, the orange symbol is surface temperature. Now let's see. Let's look at our data here. So, can you tell me what was the average surface temperature at the Old Courtyard Northwest?
It was 22.1 Celsius degrees.
Okay, see where that custom button is? Hit that custom button. Change the date to that one to March 29th. And then hit plot. Okay, so that clearly shows your surface temperature data on that date. There's more than one, but don't worry about that right now. Okay, close that pop-up window. And let's go to the other site. Let's go to the Old Courtyard Lawn site. See what we get. So that one was 22.1 degrees Celsius, right?
Yes.
Let's see. And so what's the temperature here? Okay, close that box for me. And go back to the Old Courtyard. Northwest. Go back to the other side, please. Okay. You have to assume that that is correct given the location. Click that, see that on the upper right hand corner where it says that 2, that arrow here, click to the next frame. Scroll down. That's it. Okay. Change that to ambient. Average temperature. Just click here. Just change it to air temperature. Okay, so this is the Old Courtyard Lawn, 24.4 degrees Celsius. Okay, so just keep that in mind. Close that box. Let's go to the Old Courtyard Lawn. Old Courtyard Northwest site. change that to, air temperature. So we had 16 degrees Celsius here, and the grass was how many degrees Celsius? Let's go back and take.
I think it was.
It's 22.
Okay, so we have in we write this down. We have home court yard, northwest. Oh, sure, now courtyard, lawn, and so the old courtyard lawn air temperature is 24.4 degrees Celsius. And then change that to surface temperature. This is making a little bit more sense. 22.1 degrees Celsius. Okay, so go back to the old courtyard northwest side. Surface temperature. Also 22.1 degrees Celsius. And the field thermometer temperature 16 degrees. Okay, so just okay, while you're here, see that little arrow that says 1 to 3, click on the next one. So don't worry, just go back. That's not really. All right, so this is interesting. So for the in terms of, so you had the old courtyard northwest site that had a liquid filled thermometer temperature of 60 degrees Celsius, right? Then on lawn, the temperature was 24 degrees Celsius. Does that seem like it might be off a little bit? And that's an 8 degrees Celsius difference in temperature within a few minutes. That's a big difference. But yet the surface temperature is the same. Let's do something. Take this X out of that and let's zoom in. I'm trying to see if so zoom all the way in. Okay, let's see what is at that point. Might be it's probably some cloud man. It's probably just a cloud man. All right, now in analyzing your data, which surface would you have? Well, which surface would you have expected to have a higher surface temperature? Concrete or the gravel?
The concrete.
Somehow they're both the same. So this is exactly why we do the globe activities by hand first instead of just using the app. Because clearly something's wrong. I think, I don't know, maybe this is right. I don't know, this just doesn't seem. We'll find out later. But there's something. So would you expected the lawn to be 8 degrees, over 8 degrees Celsius warmer than the concrete?
No.
No. So
Click on the old courtyard site. And let's look at. So. Yeah, go back to, current temperature, average temperature. I'm just trying to tease something. Go back, go to cloud. Same drop down. Go to clouds. All right. So we had. We have some additional data here. Oh, go to, open up the satellite match. See what's there. The other satellite. Over there, see, right here. Scroll down. Okay, so we had a basically cloudless day. And do we have leaves on the trees? Leaves
Yeah.
on the trees?
No.
I thought it was something. Oh, he said it was.
With leaves on the trees?
No.
No, so no leaves on the trees. So if you have a cloudless day, no shade over where the concrete is, there's almost no way those two surfaces should have been the same temperature, right? There's no way.
Right.
So probably, so let's do this. Well, let me step over there for a second. I'm just going to do some forensics here, some forensics in terms of what's going on here. So I guess we don't know which data set this is. But let's look at the raw data and engage in some forensics research on what might have happened here. It could be right. It could be right. I'm just curious. So let's see. So we really have let's see, whose data might this have been? So we've got that's Jocelyn. Oh, that was what's her name? This oh, here's Tyree. So let's see, let's figure this out here. That says 23 degrees Celsius. All right, let's go. So there's no name on this. No name on that one. This 17, that's not it's Jackson's, but we don't have Jackson. So here's Tyree again. This has not been converted to Celsius, so we don't know. Anyway, I can't see where the error might have taken place, but I can't. Here's mine. Let's see. So maybe this is there's 16 degrees Celsius there. So the grass is 19.5. And then the old courtyard northwest, 16 degrees for the ambient temperature. 19.5 degrees for ambient temperature. And then we haven't converted Celsius. That was supposed to have been done earlier. But anyway. That's the one thing that we don't have is maybe in the future we should put whoever collected the data. I'm pretty sure that the one that is 16 degrees, maybe that's right. And then maybe clearly the one that was 24 was entered wrong. So you really have to just kind of take your time here in your data. So the last question, of course, is, so you all are going to be teachers. So this lesson that you all just completed, how could you use that to make students have a greater understanding of the urban heat outlook? The urban heat outlook effect, UHIE. It's in, let's see what, y'all write anything down? I think you did, maybe. Let's see, let's go here. Dropbox. Let's see, maybe you just forgot. It was a long time ago. Oh, here's Tyree.
I don't think I answered. No.
Um, data. This is how, let's see. We got keep it descriptions. Yeah. So, well, so what is the urban heat island effect? What you remember from your studies? Urban heat island effect. Thank you, group one. So those are our pre-service teachers presenting their role data using role data visualization system. And so just had a couple of errors, but it happens. Next time, just be more careful. But it's very important that, well, data entry and data visualization is the most important part of Globe. That's how your students can see their data on the map. So thank you very much. Move on. And so we're off to a great start today. And so the students successfully enter the data into the Globe data visualization system, as you can see. And we just had, a boo-boo here and there, but it happens. But at least we can see that. Well, one thing you should notice is that, well, this is interesting, at least as far as the students that were using the app that day. Look at where some of the points wound up. One was over here. Were we over here? No, nobody was over there. And let's see. Nobody was over here really. But it's interesting, the people who were using the app right at the Old Courtyard Northwest site, it was pretty close. Can't say the same for the other sites, but in general, the which points are, I asked the whole class this, which points appear to be more accurate in terms of their actual location? The people who are using that Global Observer app, or people who were, or the teachers? Yes, was it the people that were using the Global Observer app that day, or remember the teachers weren't using the Global Observer app first? So which points wound up being more accurate? Yeah. So teachers, how did you get your latitude, longitude data? The GPS receiver. Yeah, the GPS receiver. So again, you should always double check when you gather data with the device, because remember, these things this clearly shows that these devices are not nearly as accurate as a GPS receiver in terms of absolute location. All right, so we'll move on, and we are continuing with our observation of Earth Week at Tennessee State University. And so our second group is going to be Matthews, Hall, Mitchell, and McAdoo. And let's see, let me know which one of these is yours. Is that yours? No, I think that's McElroy's. So is that yours, Matthews, or is it this one? Let me see. I can go. Let me see if I can. Oh yeah, this is, yeah, that's Rayco, Rogers, and Randolph. So this one probably has to be. What in the world is going on? Yeah, so Harris is in McElroy's group. Let's see. That's my data. All right. See, Matthews, Hall, Mitchell, and McAdoo. So we go right to the source. No goofballing around here. Okay, so this one is definitely Matthews. It's just the same one. All right, so we're going to have the next group, Matthews group. So you all come up, your name, where you're from, classification, and you make cameras up there. My name is Nick Matthews from Detroit, Michigan, and I'm entering the electrical engineering.
My name is Tamia Hall. I'm from Milwaukee, Wisconsin, and my major is healthcare admin.
Okay, well, obviously there are some issues, but that's fine. It's the first time these students are using GIS. Wow. I don't know if this can be fixed. Maybe. First thing we have to do is go to content. So whoever's going to be the pilot for the content. Now let's see. So click on current temperature. Go to the symbols.
This one?
Yeah, change style. But don't do it. Second, it's on current temperature, liquid fill thermometer. Okay, close that out. Go to surface temperature. Change style. Okay, close that one out. All right, go to the legend. Something is seriously wrong. Zoom in a little bit. Okay, try this. No. Zoom out, zoom out. Let's see something. Go to open in map viewer. Open map viewer. Click no, proceed without saving. See what we get here. Same thing, basically. Okay, go back to map, open in map viewer classic. Oh, okay. Wow, that's okay. Wow, just they stay right there. I think it was a visibility issue. Don't zoom in or zoom out at all. Okay, just keep right there. So now we see both sites. Okay. So click right. Well, really, what this group. Well, I'll ask them. In your case, which surface had the highest higher temperature?
The concrete.
So you can clearly see the symbology here, 36 degrees Celsius there. Then the current temperature at that same location is 18 degrees Celsius. So the first thing that you notice clearly with the map symbology is the significant difference between the ambient temperature or air temperature and the surface temperature, right? Okay, so now let's look at the, so if you look at the other side, look, what's really driving
about 17 million.
what's really driving the symbols here is, of course, the range of the data, right? So you have with the computer, the program itself selected the range of the data relative to the radii of the symbols. So from 17 to 18, look at how dramatic a change we have in terms of the size of the symbol, which is good because if we took this in from the relative size only going from 1 degree in Celsius to the next, we would hardly see any difference, right? But we want the map reader to understand that there is a difference between the surface temperature or current temperature at on the grass, which you can barely see, but that's only 1 degree difference. So it depends upon what type of message that you want to convey to the map reader. You can literally manipulate what shows up on that map by choosing what range of data matches your radii, right? So let's say you wanted to convince the city that you needed more trees in your community, right? Now, the untrained eye would say, wow, you know, Well, actually, you say, wow, we really need to cool off this concrete area with maybe some trees or some green space. Look at how much hotter it is than the grass. Right? But it really isn't that much hotter. Only 1 degree. So this just shows you how you can really hammer home a point to the map reader by understanding the relationship between your data and map symbols. Just wanted to make that point. Okay, click on the grass area. Okay, scroll down, we'll drag the whole map. All right, let's see what we have. So, go to 2. Go back to 1.
That's weird.
So this is interesting. So let's see. So for the Old Courtyard lawn site, as we're analyzing our data, let's see. So we have the IRT, infrared thermometer data, temperature at 29.5 degrees Celsius. And the liquid filled thermometer data is at 17 degrees Celsius. So go back to the Old Courtyard Northwest site. So we have the liquid filled thermometer temperature is 18 degrees Celsius. And infrared thermometer for surface temperature is 36.1 degrees Celsius. So for the concrete surface, the difference in temperature is how many degrees Celsius? No. What's the difference? What's the difference in temperature between the current temperature and the average surface temperature on concrete? What's 36 minus 18? So you have 18 degrees Celsius difference. Go back to the Old Courtyard lawn site. Hopefully you'll see it. Okay. So the difference there is 29 minus 17, but that's about 12.5 degrees Celsius difference. So is that an expected result? How so? Well, the grass is less hot, but in terms of the difference between the air temperature and surface temperature, how is that different? Yeah, there's less difference on the grass, even though the current temperature is almost the same, right? So you had 18 degrees Celsius on the concrete for the current temperature, 17 degrees Celsius for the grass, but there's a much bigger difference between the ambient temperature for the concrete and the current temperature. So you can clearly see the effect that the concrete has in terms of increasing the temperature there. Close that box. Let's take a look at the our base map. Just zoom in a little bit. We might lose the oh, it's still there. I just need to see it. Yeah. So clearly, this is a little bit off. We were here, not over there, but it could have been a GPS receiver, could be human error, who knows. But notice that we didn't have any clouds in the sky, so both of these points had receiving about the same amount of sunlight. So, given that, I'll take us to our last question. How could this experiment help you to understand the physical processes associated with urban heat island? Well, it seems like you're not in the okay, yeah, and?
So meaning like the grass would be cooler than the concrete.
Yeah, so one of the questions I asked you to answer on the assignment was, in terms of mitigation, how can we mitigate the issue of urban heat island? What's interesting is even though the concrete has a relatively high albedo, it's still pushing temperatures up. And so maybe you can see, well, it's somewhat of a difference. I mean, you have what, a 6 degrees Celsius difference in amplification of temperature with the concrete versus the grass. And so from aspect of health, you might think, 6 degrees, what's the big deal? But every degree of Celsius that we can cool down the city results in thousands less childhood emergency room visits for asthma. So every degree, just even each degree of Celsius that we can lower temperatures in the community, we can significantly lower the risk of pediatric asthma attacks through this process. And so if you wanted to convince a city or state, or specifically this would be a local government issue, to invest more in green space, increase tree planting, maybe increasing park space, lowering the albedo of surfaces in certain communities that have high risk for pediatric asthma. A map like this would really solidify that, really solidify the argument, even more than medical. So thank you very much, Matthews and Hall. Someone left the phone up here. I don't know whose it is. All right, so let's see. That was that group. So we're having a great day today here at TSU. Observation of Earth Week. Looking at, okay, so that was group 2. So group 3 is come up next. Racco, Randolph, and Rogers. And let's see, which map is this? It's not that one. It's not that one. Not that one either. It's gonna have to be this one. Yep, it's this one. All right. So come forward. Name, major, where you're from, classification.
All right, I'm Martina Rocco. I'm a junior. I'm a biology major, and I'm from Catania, Sicily.
I'm Shamori Rogers. I'm a freshman communication major and economics.
Okay, well, here's your map. Interesting. Looks like we have another well done here with this map. The other map somehow was using my data. So that's fine. So let's see whose data we're using here. Go to content. Whose teacher's data we're using? Let's see. Miss Tyree's. This is Tyree's data on display. Here, okay, close that. All right, let's see. Zoom in a little bit. All right, so let's go back to our legend. Legend.
Oh.
There. All right, scroll down, let's scroll down. So the current temperature we have, maxing out at 23 degrees Celsius. And now this is interesting. Okay, what is wrong with your data range? Clearly. Just look at it, and then look at the map, and then look at your data range, and then look at the map. Look at the numbers, and look at the map. See anything wrong right off the bat? Okay, your maximum average surface temperature is what? No, surface temperature.
Oh. 32.5.
Okay, should that symbol be smaller than one that's 20, what is it, 23?
23.
Okay, so let's try to fix it. I don't know if this can be fixed. This could be a irreparable error. I don't know. Go to content. Let's see if we can fix it. I don't know. This is bad. Go to change. No, go to the. Let's see. So the error is with surface temperature. So go there. Go to surface temperature. Surface temperature layer.
Oh.
Yeah, right there, and go to change style. Go to options. Let's go to symbols. Let's see if we can fix this. Okay. See if you can adjust the symbol size. You might not be able to adjust. You can't adjust it. You can't adjust it there. Well, just pick the shape. Just pick one. See if you want that's not do it. Pick one outline. Maybe outline. Okay, quick cancel. Let's see. Scroll down in this. Okay, here we go. All right. So let's see. Now this is pretty bad. I don't know if it can be fixed. Make that max pixel size like 100. Make it 150. All right. Now hit OK. Now hit done. Now go to legend. See what happens. See what that is. Go to legend. That's a little bit better. Scroll down. Okay, we're getting somewhere now. Scroll up. Let's see. So let's go back to content. Current temp. Let's do this current. Let's work at current temperature. Change style. It's options. Scroll down. Let's change that max to like 25. There's some additional errors in here that, like, okay, hit OK. That might work. Okay, that's working for us. Hit done. Go to legend. All right. Scroll down. Okay, I think this is working for us. Scroll up. It's still not quite right. Zoom in on the point that's in the grass. Oh, I know what to do. I know how to fix it. Okay, go back to content. Let's do current temperature. The current temperature. Yeah. Change style. Options. Scroll down. Let's make the minimum symbol size like let's make it 20. Let's make it 15. See what happens. Let's go 15. Not
Ooh.
no, 15.
Nope.
Hit OK. Okay, hit done. Okay, let's see. I don't like the way that looks. Okay, go back to legend. See, scroll down. So go down, scroll down. 27, that is, scroll up. That's still not right. Okay, go back to content. Go to average surface temperature. Change style. Options. Scroll down. Scroll down. I mean, go, you ready. Okay, let's make this. Let's see, 32.5 is the max. Let's see what 60 looks like. No, not there, not there.
As a minimum?
60, yeah, 60. Hit OK. That might just, we got one more thing. Get done. Okay, go to the legend. All right, scroll down. Let's see. That'll just have to work for now. Okay, so now notice that you can clearly see that your surface temperature is greater than the current air temperature on the concrete. And then when we look at the grass surface, the current average temperature is 22 degrees Celsius. Scroll down, see what's there. 27. Okay, let's go back to content and go to adjust that one. Go to average surface temperature. And then hit change style. And go to options. Let's push that, scroll down. Let's push that minimum to 75. No, make it 80 pixels. 80 pixels. I think that'll get us going. You hit OK. Done. And then, okay, that's it. That's it right there. So wait. So, yeah. So notice now, so we can clearly see with our symbology that the concrete is significantly higher than, or creates a significant higher temperature boost than the grass. The only thing is, scroll down. I think this is about right. Scroll up. Yeah. So we also can see, but what's interesting is, here's what's really interesting, right? Notice that the current temperature for the grass is actually higher than the current temperature over the concrete, right? And even though the concrete temperature is lower than the grass, the net effect of the concrete pushes its temperature significantly higher than the grass surface. So you can clearly see that even though the grass starts out hotter, the surface does not allow for those temperatures to get much farther than 5 degrees Celsius. But the difference between click on the concrete and you actually see the difference. So notice we have what, a 9 degrees, almost a 10 degrees Celsius difference on the concrete, even though the ambient temperature is cooler. So this really shows how much hotter the human-built environment can push temperatures. And conversely, it shows how great an effect increasing green space and natural surfaces can have in lowering temperature. So if you remember the convention center in the Music City Center has a green roof. And from an engineering standpoint, if you have a green roof on a building, you can see how much electric energy savings you could have with that kind of building design. So just wanted to walk through looking at your data, paying attention to your symbols, and making sure that your symbols match your data. Because at first they didn't. All right, thank you very much, group 3. Good job. And let's see, we got group 4 up next. That's McElroy, Harris, Dogan, and Peterson. So which, let's see, that is, it's not, oh, that's yours?
Yeah.
All right, good, it's already up. Let's see what we have here. This one looks pretty good so far. All right, so same thing, cameras up there. Name, major, where you're from. Blah, blah, blah.
I'm McKenna Harris. I'm from Pleasantview, Tennessee, and I'm an agriculture major.
I'm Caroline. I'm from St. Louis. I'm a senior and I'm a business admin major with Constitution.
I'm Jeanette. I'm a freshman from St. Louis, and my major is chemistry.
I'm Irene McElroy. I'm a junior majoring agricultural science, concentrating environmental science from Detroit, Michigan.
Okay, who's gonna be our pilot?
Like everybody else is taken.
Oh, this is our last group of the day, and then we'll do some stuff. Go to your legend. Who we have? Let's look at our, let's see. Oh, wow. Okay, let's see. Gee. Okay, clearly there are some errors here, but don't worry. We might be able to work around it. Okay. No, don't do that. Just click on the Old Courtyard Northwest symbol. No, the courtyard, not the lawn.
Oh,
It's-
this one.
Let's see what we have. Drag the whole map down. Drag the map. Yeah, okay, there you go. All right, let's see. So we have using Jackson's data. And I see which one now. Okay, I see exactly which one. Okay,
It might be in Celsius.
no, you have a slash in
Oh, I
your
see.
data table. All right. Let me see if I can time. Oh yeah. Let me see if I can do some surgery here on your, you know what? Can't. What one of you will have to do is sign into your account. That's the first thing. So you can sign into your ArcGIS Online account.
I was like, I don't think I remember saving you.
Anyone can sign in. Okay, so what we're going to try to do is fix that mistake in the database very quickly. But in order to do that, the students have to be logged into their account. They cannot logged into their ArcGIS Online account. Okay, so you're logged in. Okay, great. So now let's see. I have to step in for a second. So this data table allegedly is included here. And then hopefully we can fix it. So we've got GIS on 4, Harris. Here it is. And let's pop it down. Boom, boom. All right, let's see, it's in Excel format right now. All right. So let's go to wow. Okay, just take my data out of there first. Delete rows 2 and 3. Click on the whole row. Yeah, take the whole row. See, click right on that 2. Right click right on that 2. No, not that 2. This.
Oh, this 2.
Right, right.
Oh, okay.
And just hit delete. Boom. Now get rid of that row 2. Delete. All right. Let's see. Scroll. See where it says average surface temperature? Take that slash. Just leave the 34.9 in there. You take that out too at night. That's Fahrenheit. Take the 94.9 out. Okay, good. And then take everything out. Just leave that. Okay. Yep. Leave the 23. Get that dot. Get that period out of there. All right. Let's see. Scroll across. Make sure everything else is copacetic in there. Good. Going. Good. All right. Save that file. Save. You can save it as. Save. And then do wait. Go back. Now do file. Save as. Save it as common limit CSV file.
Up.
Down.
Oh, right here.
Right there. No.
This one?
CSV, down. Oh, no, not that.
Oh.
No, the common
This
limit
one.
is right there. That one.
Okay.
Okay, now you save. All right, just hit OK, yeah, whatever. All right, go back to ArcGIS Online.
Where is it? Is it this one? Yeah. Okay.
Okay, so go to content. Take the check mark off of the TSU average service time. Okay, now go to add. Layer from file. Okay, choose file. File will be in downloads. There it is, the first one. Hit open. Import layer. Okay. Okay, what about that? Change the attribute to show to surface temperature. Surface temperature, boom. Come on, there we go. Hit done. All right. Let's see. Go to legend. Scroll down. Not to the promised land yet. Okay, click on the first hit save. Hit that save. Just hit save. All right, go to the Old Courtyard Northwest site. Just click on it. Yeah. Okay, the current temperature is 19. Okay, go to the lawn site. The current temperature is 8. Okay, so that they're really close together. That's Okay, surface temperature is still blown up, but at least you have current temperature is okay. In, yeah, as long as your current temperature is okay on that, then you should be okay. Yes, because it's a number cell. All right, so let's see, let's look at our data. Click out of that. Let's look at our data again. So notice that our data points are both the same color. That's not gonna work. So let's go to content and let's go see, click on those three little dots. Go to rename. Call this TSU's average surface temperature. Okay, hit okay. All right. Click on the on-campus TSU temperature. Yeah, rename that one to TSU current temperature. Current.
No. I need that.
All right. Okay, so let's go back to the legend. All right. So I think we're good with current temperature. We just need to deal with the average surface temperature. Go ahead, scroll down a little bit. This might be okay. It's okay, but it's not okay at the same time. So let's go to content. Click on average surface temperature. Go to change style.
Is that this one?
Yeah. Okay, go to options, symbols. Click on fill. Change that to kind of, let's use a yellow shade. A light yellow, light yellow.
Like, oh, that good?
Yeah, that's fine right there. Hit okay. Hit okay. Go back, hit done. Go to legend. We still have a little bit of a problem. Go back to content. Go to change style, average temperature, change style. Go to options, symbols. Change the, go to fill. Change that transparency to maybe 75%. Oh, go all the way down to the bottom. So where's this transparency? Change that to set. Okay, yeah, that right there. That might work. Hit okay. That's gonna work. Hit okay again. Go to legend. I don't like that. I don't like that at all. It's whatever. We can see it. Not just barely. So zoom way in on the grass location. All right, let's do this. Okay, go back to content. Change style.
On the average?
Yeah. Options. Go down. Okay, let's make that minimum pixel size. Let's make that, see, our minimum is 23. Let's make that, let's see if 20, 25. Let's see if 25.
No.
Okay, hit okay. All right, hit done. Oh, wait, go back to that, change style, options, symbols, fill, See that feel like this? It's a little bit too far right there. That may or may not work. Let's see. Hit okay, hit okay. Done. I don't like that. It's looking a little better. Okay, so now go to current temperature. Change style. Options. Scroll down. Okay, scroll up. Okay, make the minimum 20. This is okay. It doesn't make any sense. Okay, hit done. Okay, go to legend. Okay, zoom out. This should get what we want. Boom. Okay, so it's not pretty, but and hit save one time. You know, load this. All right. So notice that clearly you can see now that the concrete surface clearly has same thing. Even though the current temperatures on the grass and concrete are same. Click on that concrete. Let's see. So current temperature is 19 there. Now go to the symbol that's on the grass. And that's 18 there. But luckily for us, the data in the other data table is driving the symbol size of surface temperature. Even though we still have the error that you can see at 75/23, the error is still there, but it's not going to affect the symbology for our other layers. So that's fine. So we can click out of that. Let's see. So yeah, so this is pretty much what we would expect. And again, we can see even on a day when the cloud cover wasn't much cloud cover at all, both of these points were pretty much in direct sunlight. And let's see, so click on the grass symbol, scroll down. So we have a scroll up. So we only had a 5 degrees Celsius difference there. Go to the concrete surface. And we had, we had,
Okay, there we go.
yeah, so we had what, almost a 15 degrees Celsius difference with the concrete. And you can close that out. You can clearly see how the map symbols. Now, if we zoom in, along with the base map, you can clearly, again, see the influence or the effect of the surface temperature upon temperatures in that area. Now, what will be interesting is if there was more shade over the concrete, and then we might see that be have a mitigating effect. And that's what happens when we do this same experiment in the fall where there's more leaf cover. We'll see two sites will be almost the same. Even though the grass is clearly in direct sunlight, when these trees leaf out in the fall, they significantly lower that both temperatures. Again, showing the effect of urban greening and increasing urban green space and what we call green infrastructure upon mitigating the urban heat outbreak. Okay, so we fixed your map for you. It wasn't that bad. A little damage control there. Thank you very much. After yourself. Excuse me. Oh yeah. So, all right. So last couple things, couple announcements for today. So there will be 2 Cahoots next week. So the cahoots will cover the current reading assignment. So you have reading assignment. The Unit D reading assignment, environmental problems in Russia and neighboring countries. So there will be a Kahoot covering that on Monday. And then on Wednesday, there will be another announced Kahoot that will be on a topic, secret topic. And that'll get you in the last day of class. So we will be thank you very much, everyone, for joining us for our observation of Earth Week at Tennessee State University. It's Dr. Paget signing off.